Welcome back, everybody. We're going to finish our probability notes on combinations and permutations. So we're going to start with permutations. Permutations are arranging things where order matters. For example, if there are 7 of us running for class officers of president, vice president, and secretary, how many ways can 7 of us be voted in for each seat? If 10 of us are running a race and first, second, and third place win money, then how many ways can 10 runners finish in first, second, or third place? So anything where the order that something is chosen because of how they win something or their position, that's when order will matter. So we got to talk about permutations using factorials. Factorials might be a new word for us. If I have 6 factorial, the factorial is the exclamation point. Now we'll talk tomorrow in class about how to find that on our calculators. All calculators have this button for scientific and graphing calculators. But 6 factorial means I'm going to do 6 times 5 times 4 times 3 times 2 times 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So basically, whatever number is next to your factorial or your exclamation point, you start at that value and then multiply by every single number all the way down to 1. This formula, the NPR formula, is the one that we are going to focus on. N is the total number of participants or choices or things like that. So it would be our 10 runners or our 7 classmates that are running for office. R is the number of positions available. So the 3 first, second, and third place that won money, or president, vice president, and secretary. Those are the number of positions that are available. The other thing I want to briefly talk about are the factorials themselves. So if I have 0 factorial or 1 factorial, these both equal 1. And we'll talk about that when we get into class tomorrow. But we'll come across this a few times in our notes, so I just wanted to make sure that we had that here. So our first set of examples, we're talking about the word July. How many ways can we arrange all of the letters? So there are 4 letters in July. That's our N. We have 4 letters that we're moving around total. And then there are 1, 2, 3, 4 spots because we're putting all of the letters in some kind of order. So that means 4 is R as well. Our equation would be 4p4 then. So we have 4 factorial over 4 minus 4 factorial. The top 4 factorial is 4 times 3 times 2 times 1. On the bottom, 4 minus 4 is 0 factorial, which is 1. So now we can use the 4 factorial button in our calculator, which we'll learn how to do tomorrow. Or we can type 4 times 3 times 2 times 1. Or we can do it in our brain and say 12 times 2 is 24 times 1 is 24. So there are 24 ways that we can rearrange the letters in the word July in 4 places. Part B is saying, okay, now we're only going to use 2 of the letters. So we still have 4 letters in the word July, but now there's only going to be 2 places to put them. So 4P2. So 4 factorial over 4 minus 2 factorial. On the top, 4 times 3 times 2 times 1 again. On the bottom, we have 2 factorial. 4 minus 2 is 2. 2 factorial is 2 times 1. So now, when we learn how to put this in the calculator, we can put that whole thing in the way that it is. But for right now, we can either do the math and have 24 divided by 2, or this is a fraction. And so since we have like things on the top and the bottom, we can always reduce out, and we're left with 4 times 3, which is 12. Example 2. Now we have the word pencils. Pencils has 7 letters in it. So we have 7 possible choices. That's going to be our N. How many ways can we arrange all of the letters? So we're going to have 7 spots. 7 letters, 7 spots. So that's going to be 7P7, 7 factorial over 7 minus 7 factorial. Gives us 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 7 is 0 factorial, which is 1. So we multiply all of that together and we get a total of 5,040 ways. And this is what makes me so happy for these formulas and things, because otherwise we'd be writing 5,040 different combinations for the letters in the word pencils. That's a lot. All right, letter B. Now we're only going to use 3 letters. So we still have 7 total letters, but we're only going to use 3 at a time. There's only 3 spots. So we have 7 factorial over 7 minus 3 factorial, which again, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 factorial is 4 factorial, which is 4 times 3 times 2 times 1. So we can put all this into the calculator when we learn how to do that, or we can put all this into the calculator, or we can cross these out because, again, they're common things on the top and the bottom of a fraction, and that leaves us 7 times 6 times 5, which is 7 times 30, or 210. So there's 210 ways to arrange 3 of the 7 letters in the word pencils. Ten horses are running, sorry, that should be an R, running in a race. How many different ways can the horses finish first, second, and third? So we have 10 total horses, and there's 3 places they can finish. So 10P3. So we have 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. And so we'll be left with 10 times 9 times 8, which is 720. So there's 720 ways for 10 horses to finish in first, second, and third place. 8 people serve on a committee. How many ways can a chairperson, recorder, and treasurer be chosen from the committee members? Okay, so we have 8 total people, and there are 3 positions: chairperson, recorder, treasurer. That's 3 positions. So we have 8p3 is going to be 8 factorial over 8 minus 3 factorial. So 8 over 5 factorial leaves us with 336. So there's 336 ways we can arrange 8 people on a committee to the 3 different positions. That's where we're going to stop for today. See you tomorrow.